Section 6.3 Naming Ionic Compounds. In the name of an ionic compound is made up of two elements. The name of the metal ion, which is written first, it is the same of its element name. The name of the nonmetal is obtained by using the first syllable of the element name followed by "ide." In the name of an ionic compound, a space separates the name of the cation from the name of the anion. Subscripts are not used, but they are understood because of the charge balance of the ions in the compound. Names of some common ionic compounds. Ki is potassium iodide. MgBr2, magnesium bromide. Al2O3, aluminum oxide. Metals with various charges. We have seen that the charge of an ion of a representative element can be obtained from its group number. However, it's not as easy to determine the charge of a transition element because they are typical form 2 or more positive ions. The transition elements can lose s electrons from their highest energy level as well as d electrons. This is also true for metals of representative groups 4A, 5A, such as lead and tin and bismuth. In the ionic compounds, iron is in the form of iron 2, but in other compounds it has an iron 3 form. Copper also forms two different ions, copper 1 and copper 2. When a metal can form two or more ions, it has a variable charge. Thus, for these metals, we cannot predict the ionic charge from the group number. For metals that form for two or more different ions, a naming system is needed to identify the particular cation. When a Roman numeral that is equal to the ionic charge is placed in the parentheses immediately after the name of the metal. For example, Fe2+ is named iron 2, and Fe3+ is named iron 3. Table 6.5 lists the ions in some metals that produce two or more ions. Bismuth, there's bismuth 3, bismuth 5. Chromium, chromium 2, chromium 3. Cobalt, cobalt 2, cobalt 3. Copper, copper 1, copper 2, gold, gold 1, gold 3, iron, iron 2, iron 3, lead, lead 2, lead 4, manganese, manganese 2, manganese 3, mercury, mercury 1, mercury 2, nickel, nickel 1, 2, nickel 3, and tin, tin 2, tin 4. Figure 6.2 shows some ions and their locations on the periodic table. The transition elements form more than one positive ion except for zinc 2 and cadmium 2 and silver 1, which forms only one ion. Thus, no Roman numerals are used with zinc, cadmium, and silver when naming their cations. Metals in group 4A, 5A also form more than one positive ion. For example, lead and tin in group 4 form cations with charges 2 and 4, and bismuth in group 5 forms cations with 3 and 5. When you name an ionic compound, you need to determine if a metal forms two or more ions. If it's a transition element except for zinc, cadmium, or silver, you need to write a Roman numeral in parentheses after its name to show its ionic charge. The calculation of ionic charges depends on the negative charge of the anions in the formula, as shown in sample problem 6.3. Writing formulas for the name of an ionic compound. The formula for an ionic compound is written from the first part of the name that describes the metal ion, including its charge, and the second part that specifies the nonmetal ion. Subscripts are added as needed to balance the charge. The steps writing the formula from the name of the ionic are shown in sample problem 6.4.